introduce myself quickly, I'm Steph Orpilla. I lead developer relations at Nillion, and I'm also Oceans404 on Twitter, if you want to ask questions there or say hello. So we at Nillion are building humanity's first blind computer. And the first time I heard that, I was like, what does that mean? How could a computer be blind? Computers are just reading numbers. What is that all about? But what we're building is a dual architecture network. So it is a petnet plus a coordination layer. So what the petnet is doing is it's combining different privacy enhancing technologies like MPC, garbled circuits, FHE, all types of different cryptographic primitives to do interesting math on and to do blind computation. And then the coordination layer is how we pay for all of the different operations that happen on the petnet. So whether it's like storing data, retrieving data, or running blind computation, to do any of that, what you do is you pay on the coordination layer, which is a blockchain, and then you send a ZK proof of a receipt to the petnet. And so once it knows that you've paid, you're able to perform your operation. So that's kind of what the network looks like at a high level. And we have a test net right now and also a local dev net. So when you're building your apps, you can connect to either, but I'll show you the test net today. Let's go back to this idea of blind computation. So blind computation basically just lets functions or programs be performed on secret inputs without ever revealing them or showing those values. So this is really great if you have a type of application that needs security and privacy, especially if it's combining inputs from multiple different parties. So if you've heard of like a ZK proof, that is a powerful primitive for verification or checking against a single value. But something like MPC in blind computation is powerful because you can compare secrets, add secrets, do anything with secrets from multiple parties without revealing or exposing that underlying data. So it is privacy preserving. And just to show you kind of like classic computation versus blind computation, this is a really simple addition function. It's just taking two inputs, so int1 and int2, and it's returning the sum. So there's two inputs and one output, and if you console logged these inputs in the middle of the program, you could see these in plain text. And something like that doesn't matter for an addition function, but if you think of things that have more sensitive data, maybe you don't want that data exposed. So that's where blind computation could be really great. And what a blind computation function looks like is something like this. So there's two secret inputs. You can see I've kind of put blindfolds over the two secret inputs to show that you can't actually see them, and a sum that's returned. And a big difference between blind computation and writing just like traditional programs is that you attach a who and a what to each of the secrets that you're passing into a computation. So you can see that int1 is attached to me, I'm the party providing it. Int2 is attached to my coworker Charlie. He's the party providing int2. And each of these also needs a name so that we can reference what secret the integer corresponds to. So that previous slide was just kind of a simplification of what a program could look like. But this is what it actually looks like. We have a language called Nada. It's based on Python. So if you're familiar with Python, this should look very similar. And I'll just go line by line and explain what's happening here. So on line 1, we're just importing Nada DSL, which is the library that helps the compiler understand what's going on. On line 3, we're creating that function. And then on line 4 and 5, we're defining the parties. Those are the who to who is providing the secret inputs. So on line 6, you can see for int1, party Steph, which is me, is providing the secret input. And then on line 7, you can see party 2, Charlie, is providing int2. So when this computation happens, it's completely blind, and one of the different parties, which happens to be me, Steph, will receive the output, but I won't have any idea what Charlie's input was, except for that I kind of know because I provided one of the secrets, so this is not the best example because I could just subtract the output from my original input. But you can imagine that as these get more complex, the programs get more complex, you would have no idea what different secrets were passed in. All you would know is the output. So this is an example of just a simple addition program, But we've also got 2 different libraries that help you do really interesting things with AI. So the first one is Nada AI, and we have different models that are able to be exported. So we've got linear regression, neural networks, and then some more complex ones like time series, span detection, and forecasting, and also classification. So you can do all of these things within your Nada programs, which makes them really powerful and also allows you to run blind inference, which I'll talk about next. We also have a library called Nada NumPy. So this is really similar to just the NumPy Python library that you might already be used to, and it makes it easier to just do matrix operations and any of that more complicated math within Nada. That way you don't have to write all these functions out yourself. You can just use the helpers and have a better developer experience. So what I did for this example is I created an example of linear regression on housing data with blind inference. So we're going to get into this code, but just in case anyone's not in the AI world, inference is when you take a trained model to make predictions on new data. So for this data set, I used some housing data from Kaggle, and what I did was put it into a model, and I trained the model, and then I put the model weights into a secret on Nillion, so that anytime somebody adds new inputs, they can be evaluated against those secret model weights, and it will come up with what it predicts the new price of a home that adheres to the inputs is. So let's check out this code. You can scan the QR code here. I'll give you a second for that. But this is my repo. So again, it's just doing the linear regression, and I'll open up the actual code. Okay. So this is the Nada program for linear regression. So I set it up by importing Nada NumPy and also Nada AI, and then I need the linear model from linear regression. I'm setting the precision, which is just 32. That's just what I figured was the right precision for this model. Then I create the 2 different parties, so party 0 and party 1. Those are just each of the parties that we'll use in the computation. And so the first party will be the one that's storing the secret weights of the model, and the second party is the party that's providing that new input data to figure out the price of this new home. So this data set happens to have 12 different features. We can just look at the data set really quickly on Kaggle. It's things like square footage of a house, number of bathrooms, number of bedrooms, and that all corresponds to the overall price. And that's what we'll be guessing when we pass in new inputs to run blind inference. So that was the data set with 12 different features that we're interested in. Then we take the linear regression model and tell it how many features, which is 12. Next, we load the model state, and then also the input data to compare against. And then we get the result of the blind inference. So this is just telling us the expected price of the new house based on the data that we pass in. So this program does a lot, but it's actually pretty simple. And the way that we interact with it is either through the JavaScript client for Nillion or the Python client. So I'll show you the Python code first, but we'll eventually plug this into the JavaScript side so that we can create a web app where we can actually run this program against data that we're putting in on the fly. So if I go to my main file, this is where all of the different Nillion code is happening so that it can connect to the network, store the relevant secrets in the programs, and also pay for the different operations. And in this file, I also compared the result that I'm getting from the Nada program to something from the SKLearn linear model so that we can make sure that what we're getting from the Nada program is about the same as what we would get from a different model. So we're setting the precision of the model, and then we're referencing the program that we wrote around linear regression that I just showed you. Next, we have to just establish the party names. So party 0 is the one that is passing in the secret weights, and party 1 has the new input data. And then we just do some setup so that each of the different parties has their own user key ID pair, which is just, it's kind of like a private public key for a user. Then we configure payments. So I'm just setting something up with a ledger client, and that's reading from a private key that's been funded. So you can just fund with our faucet, and then your private key will have some nil tokens that it can use to pay for any of the operations that you're doing. So next we store the program. This just stores that linear regression program in the network. And then we store the two secrets. So the first secret that we're storing is the model. So this is all of the different model weights that we found when training the data set. So the model weights are stored as a secret in Nillion. We give permissions to anyone that needs to run this program. So we'll give permissions to the front end and a couple other users. We do that by user ID, which is the user public key. So I added a couple different user IDs so that we can do this from the front end as different users. And then last of all, we store the secret. So we store the model as a secret in Nillion. And this is just a test that I did with a house that has these inputs for area, bedrooms, all of these types of things. So when we run this program, let me just zoom in here. I can just do Python 3 main, and this will run through, this will run through my script and evaluate the blind computation to figure out how much a house would cost that has these different criteria. So as the script runs, you'll see that we're getting quotes for operations. That's just estimating how much it will cost. And then once we get the quote, it will automatically pay with the private key. So it submits a payment, it stores the program, and you follow that pattern for any operation you do on Nillion. So you create a quote, which is just saying what you're going to do on the network, whether that's storing a secret, retrieving a secret, or performing a computation, and then you pay for the operation, and then you can pass the operation to the petnet. So this got the expected result. It looks like this home is about $7.6 million, which seems very expensive, but this is also what the other model got. I think this data set was like fancy homes on the East Coast, so that kind of makes sense, but I probably would not be buying this home. Maybe if ETH goes way up this cycle. Okay, so this is how you create the program and you do all of that. And the next thing I want to show you is how you make this interactive, so how you turn this into a blind app on Nillion. So I've got a starter for you all to check out. And you can find it by going to our docs, so docs.nillion.com. And then you can just go to Developer Quick Start, Build a Blind App. This will take you through all of the steps to actually building a blind app. I showed you creating a Nada project. That's what the linear regression model was. But the actual blind app uses this CRA Nillion, so a Create React App starter repo. And you can use this as your base to build whatever type of project. It has all of the payments already. It has the quoting. So all you really have to do is add your business logic. So this is what the CRA Nillion app looks like. First, I have an operations page. So you can just generate a user key and connect with the user key. And then you can perform any different types of operations. This doesn't actually have to do with the housing example, but it's just to show you that you can store secrets, retrieve secrets, store programs, all of the different operations against the testnet. But if we want to run blind inference to figure out how much the house would cost, we could use this page. So this is just another page I've spun up with React, and it's connected to the specific program ID for linear regression, and it also knows about the secret that's already been stored, and that secret is the weighted model. So I'm gonna generate a user key and connect, and now I'm gonna set some different input features for a house, and the model will tell me how much it is without actually having to see those weights. So the weights stay completely private and hidden, but we're able to run inference. So let's give it a 2,000 square foot area, 3 bedrooms, 3 bathrooms, maybe 2 stories. Nope, 2 stories. We'll say it's not on a main road, there's no guest room. We'll just say no to the rest of these, maybe 1 parking spot. So I submitted the input feature set, and now I can run blind computation on the program. So let's get the quote. This is just an estimation of how much this operation will cost on the network. It looks like it'll cost 28 UNO. So then I can pay and compute. And I should see the result of the blind computation. Come on, Wi-Fi. Let's see. Okay, so we'll just give this a minute to load. Oh, here we go. So it's saying that this house is like 4.6 million, which is also a lot. But again, this was a pretty expensive data set, so I think that's why. But this is an example of how you can plug your programs into an app and a front end really easily with our JavaScript client. So whether you're writing code in Python or JavaScript, you'll be able to create web apps if you use the CRA Nillion starter repo. So that's the linear regression model example. And I just wanted to talk quickly about our prizes. So we have 5,000 USDC in prizes. So we have 3,000 for building a blind AI project on Nillion. We have 1,000 for building a blind app, which doesn't need to use AI. And then we have 1,000 for the best tool or blockchain integration. And we also came up with a nice big list of ideas for you all. So this has ideas for each of those prize categories of the different types of things you can build. And this is linked in our prizes, so just look for Nillion ideas inside of the prize links. But there's tons of different things you can build with AI, with the different models that we've exposed in Nada AI. So you could do something with housing data, like what I did. You could do something with health or medical imaging. You could predict temperature, anything like that. For blind app ideas, one thing that I've been thinking about a lot is creating like a meeting calculator, like to calculate the cost of a meeting. If you had each of your coworkers secretly put in their salary and then you calculated how much the meeting costs based on the number of meeting minutes, I think that would be fun. You could also do things with secure voting, blind auctions, and we have examples of both of those. You can do a multiplayer game, anything that requires secrets to be stored and computed on. So anything where privacy and secret storage is important for computation. As for developer tool ideas and blockchain and app integration ideas, basically if you combine us with any other sponsor, you'd be eligible for this prize. And it's especially good if you're deploying to a bunch of the L2s. You could maybe store your store IDs on chain so that those stay on chain forever without exposing the secrets. You could create a Farcaster frame, anything like that. You could build a bridge. We're looking for anything creative, and especially things that we haven't thought of on this list. We're excited to see what you build. I think that's everything from me, and I saw that it's time, but does anyone have any questions about prizes or anything? Otherwise, we'll be at our Nillion booth, so we're happy to help all weekend long.